Alright, so in this lesson we're going to do the reciprocal of functions, okay? And we're going to introduce this using the hyperbola, okay? Which we have looked at in already, so which is really good. So we're going to learn to find asymptotes, and we're looking at essentially more vertical asymptotes, but we are looking at horizontal asymptotes too. So let's just get straight into it. Okay, so we should be relatively comfortable with this, or we should be getting there. I'm going to rewrite this as like this. So if I go y equals 1 over f of x, all right, and I'm going where f of x equals x, all right. So essentially what I've done is I've written this down, okay. Now the reason for doing this is that it won't become evident in this lesson, but the next lesson we can do the same thing and it becomes really powerful, okay. So if we make if, well, I don't want to write in highlighter, if f of x equals 0, we can find the vertical asymptote. So in this case, what's f of x? Well, f of x is x, so let's go x equals 0. Okay, so I'm substituting x for f of x, all right? Therefore, vertical asymptote at x equals 0. Now we know this, all right? So if I bring my little trick where I bring Desmos into here, okay, we can see that there is a vertical asymptote right there in that graph, okay? All right, so we can see clearly that x equals 0, which is the y-axis, there's an asymptote where the graph does not cross, okay? So if we make the denominator of like these kind of functions equal to 0 and solve for x, in this case we didn't even need to solve for x, we can find its vertical asymptote, okay? So if I look at the second one, I'm going to use a different color pen, blue, okay? So I'll make x minus 2 equals 0, therefore x equals 2, all right, because I plus 2 to both sides, okay? That will tell me the vertical asymptote. Therefore, vertical asymptote at x equals 2. Now I've got this ready on Desmos as well, so let's have a look at there. And if you can see, I can't draw on Desmos obviously, but you can see that there's a vertical asymptote at x equals 2 where the graph does not cross, okay? So it's a really powerful thing to make the denominator equal to 0 and we can find it. Now these are really easy, but you'll get things like quadratics, which it gets a bit harder, okay? Now, I want to do something else. What about the horizontal asymptote? So if we go back to the first question here, okay, we can clearly see on Desmos, on the right of your screen, you can clearly see that there's a horizontal asymptote at y equals 0. So we can write that down. I'm going to write it here. Horizontal asymptote at y equals 0. Okay. Now, how do we get that? Well, essentially what we need to do is we need to think about the extremities of x. So I'm going to draw a little axis here. So we're looking at the extremities of x. So what happens when we put an x value that's really big? So something like infinity, okay? Or an x value that's really small, like minus infinity, okay? So in this one, let's put something really big in, okay? So let's put in 1 million, okay? 1 million is a big number, okay? So if I substitute that in, what does y equal, okay? 1 over a million pretty much equals 0, okay? It's going to be a really small number. And so we can say that the horizontal asymptote will be 0 at y equals 0. Okay, so substitute a really, really big number. So when we're looking at horizontal, we're looking at the edge of x. Okay, and then we can find out what the horizontal asymptote is as well. Now, this next one, if we put 2 over, and let's put 1,000,000, so that's going to be 1,000,000 minus 2. Does that affect it much? No, it's still, like, put in your calculator, you're going to get something pretty close to 0. So imagine you put in 1,000,000,000 or a gazillion in, because that's what we're looking at. When we look at horizontal asymptotes, we're looking at the edges, okay, the edges of the graph, okay? So in this case, in the second one, also the horizontal asymptote is 0, okay? So it's something to think about. If we put a really, really big value of x, what happens to the graph, okay? Now, that's pretty much it for this lesson. Peace out.